Welcome to Unpacked, the podcast that examines how technology is reshaping business and our world. This season focuses on generative AI. My name's Stuart Black, and I'm joined by the voice of the show and the brains, Think Tank's innovation lead, Arvind Ravishankar. Nice to see you, Arvind. How is everything with you?
Hey, Stuart. Lovely to see you. It's a fantastic time to be talking about AI. Super excited.
Absolutely. And you're going to be talking to Ankur Taly, who is a leading AI scientist at Google, in your deep dive interview in a few minutes. What are we going to hear about today? Give us the headlines.
So Ankur is going to talk to us, and we're going to unpack the topic of AI hallucinations. It's something that I think anybody releasing AI products should understand deeply, because it's going to impact all of us. And yeah, we're going to dive into that with Ankur and hopefully bring out a lot of good insights.
Fantastic. But before we get to that, we're going to look at a couple of current events that are making waves in the AI world. The first story is all about just how much companies worldwide have been investing in AI over the last few years. The total value of AI investments coming in at around $930 billion between 2013 and 2022. Researchers at Stanford University data tracked the investments of over 8 million public and private companies around the globe. And one of the things they found was that the highest year for investments was 2021. So Arvind, what are your thoughts? Are you surprised by these findings? Well, how about that figure of $930 billion? Is that exactly what you thought it would be?
Wow. You know, what's interesting, Stuart, is that the 930 billion itself as a number doesn't surprise me as much, because people invest a lot in new technologies. But it's the spike in investment that is really amazing, right? So for a long time, at least for the last decade, the investments have been hovering around the 20 billion, 30 billion per year per horizon. But in the last 2 years, the investments have gone up 10x to 230 billion, 300 billion a year, clearly signaling that the market sees value in the new technology that's come out, which is generative AI. So I think we are in for an interesting ride.
Absolutely. And here we are at the start of 2024. How is the year shaping up so far, do you think?
I think I'm really bullish about investments in AI. When we talk to our customers, when we talk to our partners, when even as in different episodes of our podcast, the excitement around generative AI is real. And people are working very hard to figure out how to drive value with generative AI in the market. So I'm really bullish about investments in AI. The one thing though is the market itself, overall, the industry is a little bit in recession, right? So the market is soft from that angle. So it's anybody's guess to see how this would play out and how it'll impact AI investments. But overall, in the AI sector, I'm really bullish.
Well, that leads us to the big question. Maybe you can give us some tips. How should companies be investing this year to get the most bang for their buck?
Oh, there's tons of startups working on solving the problem of taking AI technology such as generative AI and making it real for end consumers in different apps and services. Definitely look at those startups as investment. This is if you're playing in the short term. If you want to play in the long term in AI, I would look at foundation models and companies building foundation models, because these foundation models are going to become the base layer of infrastructure for all technology in the coming decade. So if you want to play the long game, invest in foundation models.
Great tip. Our second story is all about a brand new AI tool that can create songs that sound almost exactly like the popular singers who are around today who've signed up for this new tech. We've got people like John Legend, Demi Lovato and Sia, to name just a few. This is a collaboration between Google DeepMind and YouTube. The generative AI model it's based on is called Lyria, and the actual tool is called Dream Track. So this is aimed at YouTube creators who can make a 30-second soundtrack for their videos in the style of their favorite artist. What do you think? Does this sound like music to your ears, Arvind?
Stuart, let me ask you a question there, right? So you're based in London, in Europe, and the Beatles are such a popular band, and they are they have a stellar reputation within the London market and a fan base. If someone was to recreate new music with the Beatles, what would your impressions be? How would you feel about it?
Well, you'd have to listen, wouldn't you? You wouldn't be able to ignore it. But whether it had the soul that we recognise from singers like that, that's the question for me. Is it going to be real enough?
Bingo, bingo. That's exactly right, Stuart. You hit it on the head. I think innovations like this, with this technology, is really exciting. Nobody would have thought about this when they released the technology. But it comes with both those sides, right? On one side, I love Michael Jackson, for example. And if there's new music Michael Jackson's voice, I would love to hear it because it has an
Mm.
emotional response for me. But on the other side, will AI be able to capture the soul that Michael Jackson had or the Beatles had, the energy, the personality? This is something we'll see. Time will tell us. But yeah, I would say that those are two sides of this innovation.
And with these particular new tools, the artists are signed up to it. So, how do you think we're going to see questions around royalties and rights evolve as these kind of technologies become more mainstream?
It's going to create new business models for artists, right? It's going to be another revenue stream for artists to focus, right? And I think it's fantastic. Music is such an important part of all our lives, and I'm almost sure that all of us, in moments of real happiness or even in moments of real sadness, we all go to music as our source of emotional bonding. And so, the more revenue models, the more opportunities for artists to be a part of our life and ecosystem, I support it. So, I think new business models are going to come up, and I'm really looking forward to it.
Interesting times. Well, it's time for a quick break now, and then we'll be back with Arvind's deep dive interview with Ankur Taly. Our think tank focuses on researching emerging technologies that will shape your future. From generative AI to exoskeletons, we study the impact these technologies will have on business, humanity, and our planet. And through our podcast, newsletters, and social media content, we have a direct line to a truly global emerging technology community. So if you'd like to find out more about the impact these technologies will have on your business, then reach out to our team at lab45thinktank.com.
Hi, everyone. Welcome to this episode of Unpacked. Machines, in theory, are not supposed to make mistakes. You can't imagine a calculator getting numbers incorrect when it does its math. However, artificial intelligence these days is prone to a lot of mistakes. In the world of AI, it's called AI hallucinations. Why is that? How does a machine make a mistake? How does an algorithm make a mistake? And if you are implementing AI within your enterprises, in your products, in your services, if it's going to be talking to your customers, how do you ensure that it's not making these mistakes? Is there a way to explain how AI is deriving its inputs? Is there a way to observe it? These are all really important concepts in the next couple of years that you need to know as an enterprise leader, which is going to dictate how you deploy these products within your enterprises. So, joining me today is a really exciting guest. He got his bachelor's from IIT Bombay in electrical engineering, and he got his PhD from Stanford. Um, he works at the intersection of research and product, that's his passion, and he studies artificial intelligence for a living. He currently works as a staff research scientist and researcher at Google. He studies grounding, he studies AI hallucinations, he studies explainability of AI, very deeply immersed in that subject to the point where he has co-authored integrated gradient algorithm, an algorithm which helps explain model behavior and how AI works and how it draws predictions It's a very widely cited algorithm, and he co invented this algorithm. Also, been a part of Google Brain in the last couple of years. I'm super happy to bring on Ankur Taly, Senior Research Scientist at Google. Ankur, welcome to our podcast.
Thank you, Arvind. Yeah, thank you so much for the introduction.
Tell us a little bit about, from a first principle basis, right? Why do models make mistakes, and why is it called AI hallucinations, by the way? And could you share some insights on that?
So, models making mistakes is, I think, a well known thing that has been around since the time of statistical models. Ultimately, we are training these models on some data. And so it's trying to sort of understand the relationships present in that data. Now, some of those relationships could be meaningful in that they generalize to the real world, or you can call them like causal, but there might be spurious relationships in the data which the model might pick up on, and this leads to model mistakes. I have a classic example for this, so which is from my personal experience at Google. We were analyzing a model that was trying to predict diseases from chest X-rays, like cancer, tuberculosis, and so on. And this model had very good performance. So, you trained it on a certain data set and then you evaluate it on another data set, and the performance is very good. Uh, and then we applied this algorithm integrated gradients in order to understand how is the model reasoning. And in particular, what part of the X-ray image it is looking at. So we were able to sort of backtrack the prediction and sort of highlight the region it was looking at, and it pointed at something. And so we took an image which was predicted as cancer, and we backtracked the prediction, and it highlighted certain pixels. And we got excited. Maybe this is a pathology that the model is looking at. So we go take this to a radiologist. Do you recognize this pattern? Is this model sort of also understanding a predictor of cancer? Maybe we have discovered a new predictor of cancer. So the radiologist looks at it, he zooms in, and he says, no, 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 there's nothing here. In fact, what's here is a pen mark. And so what is happening is that these images were real patient images. The ones that had disease were annotated by a radiologist. So they were underlined, so they were circled, and so on. What the model has learned to do is just detect those pen marks. And that is a pretty fine indicator of disease, right? Because wherever there is disease, you have this pen mark. But it's not it doesn't sort of generalize into the real world. So this is sort of, my favorite example for why models make mistakes. You train them on data and there are spurious relationships there that
That's
the model
amazing.
picks up on.
Ankur, I love the way you've broken it up, right? So there are relationships that make sense and translate to meaningful information in the real world. And there are relationships, the spurious ones, which actually don't make sense and there's no correlation, but it still
Right.
records it, right? And the model doesn't know the difference yet. Now, talk to us a little more about that, right? So the relationships that it puts together, um, how does it know what relationships are meaningful and not? And over a period of time, is that how a model improves? By knowing which of those relationships to give importance to. Talk to us a little bit about that. How does that play out?
I think knowing is, I wouldn't use the word knowing because it's not conscious in the sense of,
Mm,
making these choices. But as you see a lot of data, you will find certain relationships that are dominant versus certain
mm, mm,
that are these one-off. Uh, and then the dominant ones would, every time you train it on more data, you sort of the training process updates the
mm.
weights of the model in order to optimize overall performance on some held out set. So it'll pick patterns that help it the most. I'm
No,
sort of
it
oversimplifying it
makes a
here.
lot of sense, though.
Uh,
That's where the statistical weightage plays a lot of role within the rules.
you may nudge the model to favor certain relationships over others. And you can do that in a few different ways. One is by controlling what features
Mm,
go into a model. So, if you take fairness, for example, now you don't want the model to depend on any fairness sensitive features, age, race, and so on. One thing, the very least you can do is don't feed those features into the model. Exclude them from the input space. Even then, there is no guarantee that the model is not, the model could still be unfair because you could have correlated features with those. But by controlling by not explicitly putting those features in, you at least have some safeguard. Uh, you can similarly have some biases in the architecture of your model. These are called inductive biases that try to limit what kinds of relationships this model learns.
Or, in terms of gravity of seriousness, as enterprise leaders look at deploying these models today, chatbots, for example, or customer call centers are a huge application. And a lot of people are doing research on how do you integrate AI to provide better customer service. Is this going to affect those deployments? What are some things they need to keep in mind, and how do they address these problems?
Hallucinations in LLM outputs, or these non-factual utterances by them, I would say is probably the most important issue in LLM deployment. So that one of the most important things to be sort of aware of and to sort of at least work around. And there are workarounds that I can get into, but this is definitely an important problem. And the reason is, even if uh, the issue is that they can basically
Hmm.
mislead the user. The way that happens is, so as we all know, we've probably all played with ChatGPT and all the amazing LLMs out there, and we have all been sort of amazed by the fluency of the output, the insightfulness of the output, and so on. And so there's a tendency to sort of just believe these things that, if you ask a question about, let's say you're having a discussion about, the side effects of a certain drug. And then someone says, oh, let's ask ChatGPT. And then you key into ChatGPT, does this drug have this side effect? And out comes a very nice looking answer. Now, the problem is that even if there is one sentence that is hallucinatory there, that could have a huge impact on, what you do with it, on the meaning of your, on the response of your query. And it could be really misleading. So especially with these large models with chatbots and so on, it is utmost important to make sure that everything that is being said by the chatbot is factual or grounded in some knowledge
Now,
source.
this is great, Ankur. You opened up then this other emerging area, grounding, right? And this is an area you've been studying. Tell us more about that. How does grounding start to address these AI hallucination problems, these spurious relationships, the text that shouldn't be there in the summarization? Talk to us about what is the first principles of grounding and how does it address some of these problems?
Yeah. So grounding sort of goes a little bit beyond just the lack of hallucination. So the grounding requirement is that not only that you should not have any made up stuff, but everything that you output should be grounded in some knowledge source. And the knowledge source is something that I control. So let's say I want to say that everything that you output should be traceable back to Wikipedia. And this traceability is that anybody who reads the corresponding Wikipedia article should agree with what you said, that you're not quoting anything beyond that article.
Hmm. So is it just is if I understand this, is it just about defining that data set? Because when you look at ChatGPT, it's also using some form of data to answer these questions, right? It is based on some data that's beyond, that's beyond what's there within the model, right? The model doesn't store all the data, but it's referring to data sources. But sounds like grounding is about one specific data set. It's more about bounding the data set.
That's correct. That's correct. So these large models, when they create these responses,
Mm.
where do they come from, right? So one is they models are sort of pre-trained on a huge, huge corpus, and that corpus comprises various things. All the books in the world, and all web pages in the world, all Reddit pages in the world, and so on. So then, it's like massive, massive text corpus that it's trained on, and then some representation of this is stored in the model's weights. So that's one source of how it's constructing these responses. It's stored something in its head, and then it's using that. It's sort of splicing all of that together in order to construct the response. The other thing is now many of these models sort of also learn to fetch information on the fly from different sources and then assemble that to produce a response. And then that's the other source that comes in. Now, the grounding property wants that everything you say should come from this source. How you do it is up to you. You can still use all your pre-training knowledge. You can fetch from other sources, but the final thing I wanted to be such that I can trace it back to this source. That's my requirement. So if let's say I have a healthcare chatbot, then I want that everything you say should be traceable back to these set of journals that I care about and I consider authoritative in my field. How you assemble the answer is up to you.
One of the interesting things you also said in the beginning is that when the model is trained, depending on the type of data it's trained in, it could set up a set of relationships which actually don't make a lot of sense, right? And that part
Right.
comes really from the characteristic of how it learns, doesn't come from the grounding element, right?
Right.
So could you talk to us about that? I mean, how much is grounding going to solve the hallucination problem? And how do we deal with those relationships which actually don't have meaning?
Fundamentally, these models are next word predictors. I key in the input is a piece of text, and what it does is then, given this text, it tries to predict the next word that is most likely to follow, and it predicts a distribution over those words. You sample from there, you stick it to the input, and then you roll it again, and then the next word, and then the next word, and so on. So, in a sense, you can think of these as autocomplete tools. But it's incredibly powerful because it turns out a lot of tasks can be solved by clever
Hmm.
autocomplete. But now, so while you can sort of you can use this in a very creative way, this next word prediction is sort of also ultimately uh, to be blamed for hallucinations, because what it's doing is basically it looks at what it recently said and then tries to predict what will likely come right after. And so it's very associative reasoning. Uh, it's not as algorithmic as we would like it to be, where it goes all the way back and tries to understand everything that was said before and says something that is always consistent with what was said before. Uh, Although I would also say that uh, these models far surpass my and I think a lot of researchers' expectations in how smart they are. So they still amaze me from time to time, perhaps more than the amount of times they hallucinate. But they do hallucinate, and the hallucination is because of various associations that it is sort of speaking out without thinking.
It is, and it's bringing an interesting thought to my head. And it's really difficult to talk artificial intelligence and not talk a little bit of philosophy. Like it's so close to us as
Mhm.
humans. So, so
Right.
the question I have here, Ankur, and your thoughts on this, right? First off, it sounds like by grounding these models and by making them RAG enabled, we ensure that there is historical proof and data that they're drawing upon. And we derive a lot of benefit from that,
Yeah.
right? So this is where education, summarization, all these different tasks, very powerful, right? Very, very
Yeah.
powerful. But I'm also hearing of use cases where these models can be used in innovation, not just about augmentation and generation, but innovation. And for example, I want to discover a new material or I want to synthesize a new protein. These kind of tasks, there, I almost feel like that hallucinatory capability is what's going to allow it to
Yep.
get to those new patterns that we as humans are never going to see.
Yeah, exactly. I mean, if you're like writing, if you're using the model to write like a creative for an ad, the hallucination is
Exactly.
perhaps your friend, because you could have it speak these, make these statements which, don't make sense semantically, but at an artistic level, they have a nice ring to it. They have, it's
Exactly.
pleasing, or this like a nice wordplay. Yes. And in fact, so, I think you asked how difficult is this RAG thing? Is this like a straightforward thing to do? Conceptually, yes. But in practice, here is the thing you run into. So if I tune my model to only answer from these sources, the issue I run into is if I tune it too hard, then it can start to just quote
Yeah.
from those sources. It will lose its natural creativity and just start to say, okay, you want me to answer from here? Let me just say, let me just pull out sentences from here and just piece them together. Now, if your retrieval is not very good, then you will get, not so relevant answers. You won't get these on point, crisp answers. So there is this tension between the model's creativity and then limiting to a corpus.
I want to close out by again talking a little bit on the philosophy side. Um, the first question I have on that side is I'll give you an example and then we can talk through it. Um, when I asked ChatGPT to generate 20 options for substitutes for a dog leash, it gave me really good answers, right? It gave me a necktie, it gave me a leather belt, and those are all actually really good substitutes for a dog leash. Then when I asked it to give me 100 substitutes for a dog leash, it started generating things like safety pin, right? It told me that a safety pin can be used as a dog leash. So I do know that these LLMs don't have an understanding of the real world, right? So are there other like other models, other concepts within AI that are also starting to emerge, similar to LLMs, which are going to help these models understand the real world? Is there research going on in that? Could you talk about that? Is that AGI, right? Give a sense for that and your understanding of that.
Right. So this is a complex question. So let's see. Uh, so there is work on all these multimodal models. So right now, all these Chat GPT and the like, they basically learn from text corpora. So their understanding of the real world is limited to what's sort of expressed in writing. They don't quite interact with the real world, or they don't sort of. At least the pure text LLMs don't have access to what's the information available in images. Now, what's emerging are these multimodal models that will sort of learn from text corpora, image corpora, tabular data, and so on. So hopefully they'll build like a richer understanding of the real world. The other emerging thread that is coming up is to sort of think of these models as some kind of agents that can interact with the real world, and then they can sort of adjust their thinking based on what. So this is getting to sort of reinforcement learning
Mm.
like concepts. Already in your safety pin example, so if you tell ChatGPT, no, safety pin is not a good thing. It's not safe for dogs. It's not the right thing. You can find that the next response that it will take that feedback into account and then make different suggestions,
Mm.
or it might argue back saying no, or it might provide you some reasons for why it's useful, but basically it'll react to it. So that is already some towards this direction of sort of giving it feedback and then helping it sort of tweak its own response. And now right now you're giving it feedback from text. But maybe if you have these kind of, if you have robots or agents that can interact with the world in different ways, they can take some actions and then get feedback from their environment, then they can use that to sort of adjust what actions they may
So,
take.
as humans, we are constantly experiencing and testing our understanding of everything we know, right? And these
That's right.
LLMs today don't have that capability yet because they don't have a way to interact beyond what they text and chat with you. Today, they don't have a way to interact.
Yeah,
So, as they start interacting with the real world and they run their own experiments to validate what they know, then I think things will change, right? Things will change.
yeah. Right now, everything is limited to
Correct.
that chat window. Whatever you type, all this feedback is also like is basically text that gets stuck
Yep.
to the input, and that's how it reacts. But maybe there are other ways to sort of
Yep.
give
And
it
I think
feedback.
that's another thing I think it's important for our enterprise leaders to understand is that that's their corpus of knowledge, right? But the way we see this progress is more and more interfaces that are built, more and more it starts to use sensors and robotics and all these elements to interact with the real world. It's going to be able to judge for its own whether something is real or not, right? It's going to know that a safety
Right.
pin can't be used as a dog leash. Fantastic. Ankur, this was such an amazing conversation. I do think we should do another podcast because there are other topics such as explainability, observability that I would love to connect with you on. So we should find a time to do another podcast. But a lot of great information today that you've shared with us. So thank you so much and awesome having you as a guest.
Thank you so much for having me. I really enjoyed this conversation. Yeah, it was very nice. Yeah, thank you so much.
Great interview, Arvind, as always. Can you just tell us then, what were some of the key takeaways for you?
I'm going to give a lot of credit here, Stuart, to Ankur Taly, who drew out some real amazing insights for us in the conversation. I think there are three key insights that everybody should take away from what Ankur's told us. The first one is what are AI hallucinations? The second insight is about how do you solve them? And the third is what do you keep in mind? There are some trade offs as you solve for AI hallucinations. And as a leader, you should understand the trade offs. So let's start with the first one. What are AI hallucinations? So when you train AI and when it learns, it forms relationships from the data that it has been fed. And sometimes it forms meaningful relationships, sometimes it forms spurious relationships that do not make sense. And those spurious relationships that it forms, that's called AI hallucination. So when you're interacting with the model, it could say something that is completely wrong without realizing that it's giving you the wrong information. And the thing is that compared to you and me, where Stuart, we learn through our experience in the real world. Today, AI is not there yet, where it learns from an experience in the real world, right? It's learning from a set of data. So it's difficult for it to tell the difference sometimes between meaningful and spurious relationships. So it does hallucinate. So that's the first insight, right? That AI hallucinates today, and that's what AI hallucination is. The second insight was about how do you solve it. And here, one of the things that companies could do is you take this AI model and you ground its answers in a known data source, a trusted data source. And that allows the AI to draw from that data source and answer the questions. So this way, it's not giving you nonsensical outputs. Even that doesn't solve the problem completely, but at least to some degree, you can have a lot more confidence when you bring these models out. And the way this grounding methodology, one of the methods is called RAG, Retrieval Augmented Generation. So that's the terminology that people should understand and do a lot more research on RAG in order for you to solve for AI hallucination. The third part of this, which is the most interesting part I thought in our conversation, was that, you know, you could say, okay, I'm going to ground my AI models and everything is great. But the reality is that the same quality that makes AI hallucinate is also what makes AI innovative. So, if you want to develop new ideas for materials, if you want to innovate new molecular structures in biology, That ability of AI to form millions of relationships and sort through them is what makes it powerful. So you don't want to ground it to the point where it's not creative. So there's a balance there. And so it sounds like as enterprise leaders, you want to make sure that you have a really good AI team that understands those concepts and understands the balance, right, of how to ground and not ground so that you keep the creativity of the AI models. So I would say those are the three main insights for enterprise leaders. And I would, if you want to read more about this, we're going to put in some links on our podcast, and we're also going to give you ways to contact Ankur. So feel free to dig deeper into these topics. Hopefully, we've given you enough so that you can become intelligent about it and start making some decisions around it.
Fantastic stuff. I've learned a lot. And then looking ahead to next week, who do we have on the show?
Oh, it's going to be super exciting. My mentor from UC Berkeley, Professor Gregory LeBlanc. He teaches strategy, macroeconomics, and finance, and he's going to talk to us about AI transformation. What is the transformation that the world is going to see, especially enterprises, using AI, right? So exciting. I'm looking forward to unpacking that with him.
Yeah, absolutely. I'm looking forward to that one too. So all it leaves me to say is thanks to Arvind Ravashankar for plenty of brain food today. If you like our podcast, please feel free to like, subscribe, or tell your friends. I'm Stuart Black, and see you next time on Unpacked.